So welcome back, everybody. So today's going to be a quick tutorial. We're going to talk briefly about exceptions in Java. So exceptions are relatively straightforward. Essentially, the idea is that first of all, everything in Java is an object. So there's an actual object class, and everything in Java extends from that class. That's sort of at the top level. And then anything that's an exception or an error extends from at the top level. We have throwable. So that's something you throw. And then you have error. You have exception, you have all these different types of errors like linkage error, runtime exception, and all that. So we're not really interested in the errors. We're more interested in the exceptions. So you can see you have like IO exception, you have runtime exception, things that you guys might have run into already. Now there's a key difference between the types of exceptions. So actually, let me quickly check if I'm sharing my screen. I wasn't sharing my screen. So there's two types of exceptions. So there's what's known as compile time exceptions, and or rather, they're called checked and unchecked exceptions. So checked exceptions are also known as compile time exceptions. So they're basically exceptions that at compile time before running your program that they'll be thrown. So those are basically everything like IO exception, reflective. Anything that's not a runtime exception is a checked exception, because runtime is, as the name implies, it's something that happens at runtime. It's not something that can be checked before you compile. So that's referred to as an unchecked exception. So those are really the two key differences. You have basically checked exceptions and unchecked. Anything that's not a runtime exception is a checked exception. And anything that's a runtime exception or a child class of that, so like arithmetic exception, class exception, all of those are all thrown at runtime, and those are therefore unchecked exceptions. So basically, all exceptions extend from throwable, checked exceptions extend from throwable, and then a runtime exception or any unchecked exception extends from runtime exception. So any questions on that? So that's sort of the key difference between the types of exceptions. Clear? Should be straightforward. So it's important to sort of know the difference between those two, because when you actually write the code, you have to deal with the exceptions in a particular way. And it's not always obvious, which method to use. So you might have seen that sometimes you have to add the keyword throws in part of your method signature, like, this method throws value error, let's say, or that's not even an error. Let's just say arithmetic exception, right? You might have noticed that you have to do that. And sometimes you don't have to do it, whereas you're still throwing an error. So you're like, when do you use it and when do you not use it? So let's do an actual example. I just have this main method here. So what we're going to do is basically write a method. So first we'll do an example of a checked exception, something that we know will be thrown. So let's just do public static void, some method. We don't care what it is. It's just going to throw an error. And the way you throw an exception is you just use the keyword throw, and then an exception is an object, so you have to instantiate it using the new keyword, and then you can pass it some error, right? So let's just say we want to do, so let's do an example of a checked exception. So we can't do something that's, again, a runtime exception or a descendant of that. So we'll do, let's say, like an IO exception. So that's an example of a checked exception. So let's do new IO, not like that. New IO exception. We'll just say, IO error occurred. And let's go ahead and import this. Okay, so we have this exception. Now, and then let's call this method from our main method. We'll just do some method. And now you notice that there's an error, right? It says that unhandled exception type. Now I'm going to change this. So I'm going to comment this out. Now instead of, so again, this is a checked exception. Now let's do an example of an unchecked exception. So again, an unchecked exception is anything that's a runtime exception or a descendant of that. So if you look back at our diagram, an example of a runtime exception is, let's say, arithmetic exception, okay? So let's do throw new arithmetic exception. And we'll just say arithmetic error. Now notice that we have no errors now. There's no, it's not, so again, if I comment that out, that's giving me a problem. But if I throw an arithmetic exception, there's nothing wrong with that. So anybody know what's happening here? So again, it has to do with the idea of checked and unchecked exceptions.
not checking, because there isn't.
Yeah, so Java doesn't care when it comes to runtime exceptions or any descendant of a runtime exception. You don't have to handle it because it's only something that is thrown when the program is running. So you can't actually, in this case, we're throwing it manually, but this could be something like, division by 0. That's not something the program would know beforehand, right? So therefore, you don't have to deal with these. But checked exceptions are things that you know will be thrown, like a missing file, for example, that would lead to IO exception. That's something that you have to deal with. So how do we deal with these? So there's two ways that you can deal with this. One is you just add the throws keyword as part of your method signature, and you specify the type of error that will be thrown. So you do throws IO exception, but then anywhere where you call that method also has to have that as part of its method signature. So we would have to add that here as well. Okay. So now this doesn't exactly deal with the error. This sort of just satisfies sort of the Java compiler when it comes time to compile. So just so that the method signature knows that this is a possible exception that can be thrown, and it also serves as sort of a documentation for people using, let's say, your library. They know that this method could throw an exception, and they can deal with it appropriately. Whereas if that wasn't there, it would be sort of harder to figure out what exceptions are thrown and when to deal with them. So that's one thing you can do. Now let's see what happens if we actually run that. So let's go. In a bit. So let's see, we can run this. We do Java runner main or Java runner. Now notice that it says that exception in thread. So we satisfied the compiler by specifying that this is an exception will be thrown, but we haven't exactly dealt with the error. So the way you deal with an error is by using what's known as a try catch block. So you do try. You're going to put some code there. We'll look at that in a second. And then you catch. What you catch is an exception. So we'll look at this as well in a second. So basically, anything in the try, you want to try some code. Now, if you have some code that will potentially throw an error, like this one, this method can throw an IO exception. What you do is you try that code. So you put that in the try block. So you try to run that code, but it could possibly throw an error. So you need to catch that error. So in the catch block, you basically specify what error is going to be thrown. In this case, we know it's IO exception. So you specify the type, and you can just give it a name. We'll just call it E. And then inside of the catch block, you can actually deal with the exception. You can print an error message. You can maybe run some other code, whatever the case might be, right? So the most common thing is usually just printing out the error message. Oops. Now there's a number of things you can do actually. So if you do E dot, you can see a number of things. You have a bunch of generic object stuff, but then more specific to the exceptions, you can do get cause, and notice that returns a throwable object, like we discussed the throwable class, which is sort of at the top level. You can do get stack trace, which is actually what it prints by default. So notice that when we run this, this is what's referred to as a stack trace. So essentially gives you the whole stack of function calls that led to that error, right? So it shows that we had some method, and before that it was main, so it shows you the whole call stack. And you might imagine that could be many, many different methods, right? So by default, it shows you that. So let's go back. So we had E dot. So we had get stack trace, and then you can see what else can you do. Yeah, you can print the stack trace directly. Get stack trace is kind of nice because it returns an array of basically strings essentially, and you can iterate over that and maybe make like a custom exception message or something like that. Anyways, that's some of the methods that you can use, but usually you just want to print like something went wrong. But now what's going to happen is when we run this program, it's not going to actually throw the exception. It's going to deal with it because we have this try catch block. So let's run this again. And let's get rid of that. So now it just says something went wrong. So basically, it can catch the error, and it knows how to deal with that. Okay. Now, if you have, let's say, so this is an example of checked exceptions, and you have to deal with them. For runtime exceptions, you don't have to deal with them. So let's make a new method known as public static void. Let's call it another method. And this one is going to throw, instead of a checked exception, an unchecked exception. let's do throw a new runtime exception. So again, it doesn't complain that we didn't handle this. So again, that's the difference between those two. And again, you can use sort of this approach to handling these errors as well, right? So by default, it's not going to complain about runtime exceptions, but you can use this approach to handle those as well. So we could do another method. And instead of, now in this case, we have a runtime exception. So instead of IO, we would do runtime. That's the type of the error. And then we're good to go. So if we run that, do Java C. Again, we can handle both types of exceptions using this approach. Let's see, what else? So we did checked exceptions. Yeah.
When would we ever see the runtime exception, as in like the actual text runtime exception that is on line 20?
What do you mean?
Because we call throw new and runtime exception, and there's an argument inside of it, which is runtime space exception. When would we ever see that text?
Oh, so that's part of, I believe, e.message or something. e.getMessage. So if you print that, and I'll try it out right now, you can that's basically, you can get the parameter that you pass down here. You can get it using e.getMessage. Does that answer your question?
Yeah.
Let me check if that's the one, but it might be some other method. Yeah, that's the one. Okay. Now let's do a quick example of more runtime exceptions. So this is clear, right? Any other questions? Okay, should be straightforward. Instead of deleting this code, I'm just going to make another class. And let me just copy this. Don't need that. So now we were manually throwing runtime exceptions, right? But runtime exceptions are something that you don't actually know beforehand. So technically you wouldn't actually throw those manually, right? That was just for a demonstration. So let's look at when you'd actually have a runtime exception. So again, if we go back to our class hierarchy, you can see that, let me see if I can zoom in. You can see that runtime exception, it can be an arithmetic exception, array store, we have illegal argument. There's one other one I wanted to look at, and that's, yeah, array, that's like a common one you'll see, array index out of bounds, string index out of bounds. So let's do an example of that. So we can have something like int x equals 1 over 0. And then we can try and print out x. Is that going to throw an error? Yes? What kind of error? Well, yeah, it'll be runtime, but more precisely. Let's see. Well, it'll probably be arithmetic exception, I think, and that would be, division by 0 would be part of that. So let's try running that. Oops, we're running the wrong program. And we'll do Java runner 2. Yeah, so that's a arithmetic exception, and again, it prints the stack trace. Another example of a runtime exception is, let's say you have, an array. Let's say it has 3 elements, and let's say you try accessing like the third element, or the element at the third index, which obviously doesn't exist, right? Because there's only you can only go up to the second index. And let's get rid of this. Let me comment that out. So this is another runtime exception. This will give you something like index out of bounds. So we see, yeah, we get array index out of bounds. Similarly, we have string index out of bounds, which is essentially the same thing, but for strings. Now, the other interesting thing is, if we have 2 errors, what do you guys think is going to happen here? Yeah.
I was going to say check one first, and I'm guessing since we don't have any check one, it's just going to be the first one.
So is the program going to, continue executing until here, or?
Should catch the first one.
Okay. Will it catch the second error?
It shouldn't hurt to difficulties.
Okay. Yeah, that's right. So if we run this, basically, if you have multiple errors, because it crashes essentially at the first error, it's never actually going to detect the second error. And that. So again, it says arithmetic exception division by 0, but notice that it doesn't throw the array index out of bounds because it never gets there. So essentially it sees this error, it's determined at runtime, and then the program stops executing because it found an exception. So this is actually never discovered, this error down here. So that's just a little observation. Let's see what else. I wanted to briefly talk about throwing custom exceptions. So you can make your own exceptions. So again, if you look at a diagram, it's pretty comprehensive. You pretty much have everything you'd always need. You have like file IO exceptions, socket exceptions, arithmetic. You pretty much have a exception class for every scenario that you might run into. But occasionally you might want to make like your own exception class. Maybe you want more like verbose debugging messages, or you want to handle, maybe you want to catch that error and handle it in a particular way or something. So you might want to make your own class. So we'll do an example of that. Let's do custom exception.java. Now, again, there's two types of exceptions. Anybody remember? Yeah, and so what did checked exceptions extend from? So anything that's runtime or a descendant of that is unchecked, and everything else is checked. So basically, if you want to make a checked exception, you don't extend from an exception, you would extend from throwable. I'm not sure why, that's just how people do it. And then if you want to make a unchecked exception, you just extend from runtime exception. So let's do a quick example. So we want to make, this is an example of custom checked exception. So this is going to extend from throwable. So extends throwable. And then don't remember what the methods are, so let's take a look. So you can see we have, this is our constructor for the throwable class. So we have a number of different constructors. So let's actually take a look at those. That might be interesting. So you can instantiate, a checked exception with just a string message, like we were doing. We were throwing the exception, we passed it a message. Then you can also do string message. You can also do throwable cause. I actually haven't seen this very much, so I'm not sure when people use this, but that's just, you can have multiple constructors and instantiate things differently. You can instantiate it with just a cause. You can instantiate it with a message cause and a bunch of different things. And by the way, if you're ever curious as to how something works, you can just, in VS Code, you can just do go to definition, and that opens the actual source code. Like this isn't my code, obviously. This is like the Java source code. You can look at, what's happening behind the scenes. So, that's useful sometimes to figure things out. But yeah, I imagine what we do here is public custom exception. And then again, it takes, so we have multiple constructors. We'll just go with the string message one. So we'll do string message. And then we'll just do super, which just calls the parent class's constructor method. And that's all. So, and then we can use this like we would use any other exception. So we can do runner3.java. Let me copy the main method. And we can use that custom exception we just made. Let's just call it E, new exception. So you can instantiate it. And by the way, does anyone know what happens if you just instantiate a exception object? Anyone know? So what's the difference between doing this versus like throw new custom exception? Let me fix this. So what's the difference between first and second line? Anybody know the difference?
First one, you create an object.
Yeah, so the first one, you're essentially, you're creating an object instance of it, but would that actually throw the error? Okay, why not? Well, essentially, you always need the throw keyword if you want to throw an error. So this line, and again, it's complaining because we don't have it in the method signature. So this line will actually throw the error, but this line actually just creates the object, and then you can do whatever you want with the object. You can do e dot, all those methods we looked at earlier, but you can also do throw e, right? Because e is just new exception. So you could also just do that. So that's just a little thing to keep in mind. Instantiating an exception won't actually throw it. You have to use a throw keyword. So maybe it might be useful sometimes to just instantiate the object, do something with it, and maybe you want to throw it later. So just to make that more clear, just instantiating this object won't actually do anything. And maybe we can just do like, just for demonstration, dot get message. And again, you can get the message even if the error isn't being thrown, because that's just it's just a field that's part of the class. Runner 3. We have a runner 3. Yeah, so again, no error was thrown. There's no stack trace or anything like that. If you actually want to throw the error, you would do throw, right? So we do throw E. So just for demonstration. Now it actually throws the exception. Okay, so any questions about that? So that's instantiating an exception versus actually throwing it. So those are two different things. Any other questions? Okay, let's just do one more example of, so this is a checked exception, so we extend from throwable. Now we'll do a slightly different example of a custom runtime exception. So that's slightly different. Again, let me copy the main method, or I don't need that yet, actually. Runtime exception, close everything. Okay, so if you want to make a runtime exception, so this is a custom checked exception. So this is going to extend from runtime exception rather than throwable. Okay, so that's the difference. So instead of extends throwable like we did earlier, we're going to do extends runtime exception. And then again, you can again look into the source code for runtime exception and see what the different ways of creating it is. The most basic way is just passing a string message or string message with cause, so similar to throwable that we already saw. So we'll just do that. We'll just do public custom, so our constructor, we're just going to pass it a message, and then we'll just call the superclass. Okay. So these are really simple examples, but you can imagine maybe you want, you're not always going to have these simple applications that you're just running from the command line, right? So Java applications are used for like a whole variety of things. So one of the things that they're used for is in distributed systems. And in distributed systems, logging is like a really important thing because your code is running on different servers, and it can be hard to debug issues if you don't have proper logging in place. So you can imagine sometimes what you might want to do is create custom exceptions and then add like very detailed exception messages, so that helps you with debugging. So that's just one example of where you might want to use it. And let's make one more runner class. So just to run this exception, just to demonstrate that we can use this like any other class. Let me copy this. Custom runner 4. So we don't need to add the throws now because we have a custom runtime exception. So let's do custom runtime exception, E equals new custom runtime exception. Again, we can add whatever message. So you can use this like you would with any other class, and then you can throw it, whatever, right? So that's just an example of custom classes. So that's pretty much it. So the key takeaways are, all you need to know is that there's two types of exceptions in Java, checked and unchecked. Unchecked exceptions are those that you can't know beforehand, things like division by 0, array index out of bounds, because that's something that's dynamic. It's going to be figured out at runtime. So anything, and as the name implies for runtime exception, anything that is a runtime exception or a descendant of that are all unchecked exceptions, and they'll be thrown at runtime. Whereas pretty much everything else is a checked exception. Those are things that you have to deal with beforehand. So the next time you're writing something in Java and you're trying to understand why is it complaining or why is it asking me to add this throws IO exception, all you need to understand is if you're throwing a checked exception, so if you're throwing anything that's not a runtime exception or a descendant of that, you need this throws IO exception as part of the method. And yeah, so you pretty much need that. Now the try catch is up to you how you want to deal with it, or if you even want to deal with it, that's whatever. But you will need this always if you are throwing something that's not a runtime exception. So as soon as I remove that, it's going to start complaining. but for the runtime exception method, it doesn't complain. And again, you can make your custom exceptions, and you can again have checked and unchecked custom exceptions. So if you want to make a checked custom exception, or this is actually an unchecked exception. So if you want a custom unchecked exception, you would extend from the class runtime exception. And as we saw in the source code for runtime exception, there's a number of different constructors that you can use. This being one of them, you just pass a string message. And then we can also have custom exceptions that are checked. And then for those, you extend the throwable class rather than the runtime exception. So that's all. So if you have any questions, I'll be here for a while.